In this video, we're going to be talking about how, or proving rather, how trade can make everyone better off. Now, I highly recommend that you sit with a paper and a pencil or a pen, and also with a calculator, and also have a fresh and open mind and listen to the next few minutes. Okay, it is going to be a little longer than the rest of the videos, but we have to do this all at once, so pay attention, and you cannot do this video by just intermittently. Okay, sit and do it at once. Now, when we're thinking about trade, we obviously are talking about at least two countries. Okay, so the assumptions we're going to make to prove this point is that we have two countries, the United States and Japan, that are going to decide to trade or not trade with one another. And then again, we're going to be rolling with the same examples that we had in chapter 2, that both countries can produce two goods that are iPads and masks, and they have one resource, both have one resource, which is labor, and that is measured in labor hours. Okay, so the number of hours worked. Now, to prove that trade can make everyone better off, we are going to consider two cases. The first case is what is going on with the two countries when they don't trade with one another, when there's no trade happening, and they choose to be self-sufficient. Okay, and the second case we will consider, second situation we will consider, is when they do decide to trade and when they become economically interdependent. So as far as the United States goes, we are going to roll with the same numbers as before, so we don't spend too much time on that, but you can go back to chapter 2 and look at how we derived the production possibilities frontier for the United States. Okay, so just to recap, we were thinking about the two goods, iPads and masks, and for one iPad in the United States we required 100 hours of labor, and to produce one box of masks we required 10 hours. Okay, and we were endowed with 50,000 hours that were available for production. Okay, so again, remember that table where the points on the graph would be on this side, on the left side, or the first column, and then the second and the third column tell us about how labor hours are allocated between iPad and mask production. So let's say again that we had 50,000 labor hours and all of those hours go to iPad production. Then we're not left with anything for mask production, and as a result we don't produce any masks. Okay, so the last two columns here are representing what we can produce of the two goods. Okay, and so if all of the hours are going into iPad production, we end up producing 500 iPads. Okay, similarly we can come up with different numbers where if we split the hours evenly between iPad production and mask production, we end up with 250 iPads and 2,500 masks. Okay, and finally, if you want to take, if you like zeros like me, not on your tests, but just here to make graphs, if we don't spend any hours producing iPads, then we don't get any iPads in the end, and all of the hours go to mask production, and we end up with 5,000 masks. Okay, so we can take these points, really we need 2 points, A and C, you can call them whatever, but you can plot these 2 points, 500 0 and 0 5,000, to obtain to construct the production possibilities frontier for the United States. Okay, so here is the production possibilities frontier for the United States, and let's think about a situation, the first situation where we said the United States does not trade. Okay, so if it does not trade, it might actually want to produce some of both goods. Okay, so it may not want to choose those points like 500 or 5000, because it might actually want to have both goods, okay, under no trade. Okay, so it might choose a point like 250, 2500, which was obtained when we were splitting the hours evenly. Okay, so we can ask ourselves this question: how much can we consume of iPads and masks if we produced this much? Okay, if we are not trading with any other country, then you can imagine that our consumption is going to be equal to our production, and this is always going to hold under no trade. Okay, that what you're going to be able to consume as a consumer in terms of iPads and masks is going to be equal to production, because we don't have any trade going on with another country where we can maybe get more iPads or more masks from another place. Okay, so consumption always equals production under no trade, and so we are going to be left with, if this was that point which represents 250, 2500, at this point production and consumption are equal to each other. Okay, now let's try to turn to the Japanese economy. Now this all might look similar colors and everything, but really this is for Japan. Okay, so now the numbers are going to be different, so I'd like you to pay attention to this. Japan also can produce iPads and masks. The only difference here is that I'll mark the difference with another color. So in Japan, one iPad takes 125 hours and one box of masks takes 25 hours to produce. Okay, and Japan, being a smaller country, is also endowed with less labor hours. Maybe it has less people. Of course, Japan has a problem with a declining population. So it has 30,000 labor hours available to it. So this is a good time to pause and try to fill in this table so you can draw the production possibilities frontier for Japan. Okay, and if you'd like, you can take all of 30,000 hours here. Maybe we can make it with a different color. Okay, so 30,000 hours go in here. You can fill out the rest of the rows, and you can split the hours evenly, and you can work with zeros. Okay, so you can fill out the rest of the rows and pause the video here. Okay, so let's try to do this now. Look at the first row. If we spend 30,000 hours in Japan, not we, but the Japanese spend 30,000 hours on iPad production, then they can get, if one iPad, this is to recap your basics of how you're going to calculate this. If one iPad requires 125 hours to produce in Japan, then with 30,000 hours, let's say we want to calculate X iPads, right? How many iPads can be produced? This is what we want to find out. So you cross multiply and you will get 30,000 equals 125x, right? So you solve for x equals 30,000 divided by 125, which is 240. Okay, 240 iPads. So I'm going to put in the number 240 over here. And similarly, if we're not spending any hours towards mask production, then we aren't getting any masks as our output. Okay, Now let's think about the case when the hours are split evenly between iPad production and mask production. So if you divide 15,000 by 125, you would get 120 iPads, okay? And if you divide 15,000 by 25, you would get 600 masks, okay? And again, coming to the last row, if we don't spend any time on iPad production, we don't get any iPads in the end. And if we spend all of our time on mask production in Japan, then we get 1,200 boxes of masks. Okay, so this is how we can use these 3 points to construct the Japanese production possibilities frontier. Okay, so which looks like this. Okay, so now again, think about the fact that if we are thinking about that first case scenario where the Japanese are not trading with the United States or not trading at all, then we might not be operating at points like the y-intercept or the x-intercept. Why? Because the Japanese might want both iPads and masks. So they might choose a point like 120, 600, which was where hours were split evenly, or some other point where both goods are being produced. Okay, and so we want to find out what is consumption then. Okay, and remember, under no trade, the condition that's satisfied is consumption equals production. Okay, so if the Japanese are producing 120 iPads and 600 boxes of masks, they can also consume the same amount. Okay, nothing less, nothing more than that. Now, we're switching gears now, and we are going to be talking about production under trade. Okay. Now these are made up numbers. It can be anything, but just for the sake of our example, we're going to roll with these numbers. So suppose the United States decides that it wants to produce 3,400 boxes of masks. Okay. The question for you is, how many iPads can the US produce? And similarly, suppose Japan decides to produce 240 iPads. How many boxes of masks can Japan produce? This is a good time to pause the video. Now, suppose the United States decides to produce 3,400 boxes of masks. If you think about it, one box takes 10 hours. So if we want to produce 3,400 boxes of masks, that would require 34,000 hours, which means only 16,000 out of 50,000 would have been left for iPad production. And so if 16,000 hours are left for iPad production, we would be able to produce 160 iPads. Okay, so that's the answer here. How many iPads can the US produce? 160 iPads. Okay, so we will assume that 160 and 3,400 is the point, or is the production combination that the United States chooses if it decides to trade. It can be different, but this is what the question is telling us. Okay, and suppose Japan, coming to the second question here, suppose Japan decides to produce 240 iPads. Okay, so we just saw that for Japan, if Japan is producing 240 iPads, then it will not produce any masks. Okay, so how many boxes of masks can it produce? The answer is 0. Okay, so Japan will basically operate at a point which is 240 under trade. So let's highlight these points so we don't forget. Okay, this is the point for the first point is for the United States, and the second point is for Japan. Okay, under trade. Now obviously both countries, and just to kind of make one more point about Japan actually can try to produce this type of a combination where it only produces iPads and produces nothing or no boxes of masks, because it can obviously trade. It's deciding that this can be the production combination under trade, so it can trade with another country and get those boxes of masks that it is not producing. Okay, so let's turn to some of the jargon that comes up in economics, which is about imports and exports. Okay, so exports are goods and services that are produced domestically and sold abroad. I'll also say to foreigners, okay, and we'll make that point in a minute. And imports, on the other hand, when we think about any imported good, most of what we consume is imported. I can't remember the last thing I purchased that was made in the United States. Imports are goods and services that are produced abroad and sold domestically. Okay, so these terms are basic, but it is important to not skip this concept. But there's a subtle point that I want to mention, that sometimes this comes up in lectures, okay? Especially because tourism is an important part of our local economy. Okay, so suppose someone from Germany or South Korea visits San Francisco and spends $200 on watching Hamilton, the show Hamilton. Okay, how should we classify this and other expenditures by foreign tourists on entertainment while they are vacationing here? Okay, the idea is that if a German tourist, or any other tourist for that matter, any foreigner, buys or spends some dollars on a show in anywhere in the US, we count it as US exports. Okay, so what matters is that it was produced here but sold to a foreign buyer. Okay, so this is why I was making that point earlier. So a more precise definition of exports would be that goods and services produced here and are purchased by foreign buyers. So this is a stricter definition of exports, and so it's important to clarify that point. Similarly, a stricter definition and a more precise definition of imports would include purchases by domestic residents of goods and services produced abroad. Okay, so including entertainment and lodging services that tourists from the US consume when they visit foreign countries. Okay, so we understand this point, and we'll just roll with that and try to understand how do we, what can we say about consumption with trade. Okay, so remember, under no trade, production and consumption were equal to each other. But under trade, what we can consume is different than what we can consume without trade. Okay, so consumption with trade is going to be all that we produce with trade, or whatever we decide to produce under trade. I can write production here to be consistent. So production under trade plus any imports that we have of that good. So if we were thinking about iPads, we're saying that consumption of iPads with trade equals the production of iPads with trade plus the imports of iPads minus the exports of iPads, right? And so logically speaking, this should be easy to write out. Okay, don't try to memorize this, but just try to understand this. What we can consume equals production plus whatever we import from another country minus whatever we are exporting to another country, because when we're exporting, we're giving it away. Okay, so that's subtracted off in the end. Okay, so remember this, and we're going to use this a lot in the next exercise. So this is a critical slide. Okay, and it is important that we fill out these blanks as we know them. Okay, so the first thing we want to do is read what's given to us. So it says, suppose the United States exports 700 boxes of masks to Japan and imports 110 iPads from Japan. How much of each good is consumed in each country? To answer this, we would have to make a table which has the first two columns here represent the United States and the two goods, iPads and masks, and the last two columns represent Japan, and again the two goods, iPads and masks. And on the extreme left panel, each row is describing what's going on. Okay, so think about production under trade. What was that combination for the United States when the United States decided that it will trade? Okay, so it was deciding that it would produce, let's go back to that combination, 160, 30, 400. Okay, so we're going to write that down here. 160, 30, 400. And similarly for Japan, Japan decided that it would produce 240 iPads and no masks. Okay, now let's try to fill out these two lines, these two rows, by just looking at what information is given to us. Okay, this is a good time to pause the video and fill out these two rows. So suppose the United States exports 700 boxes of masks to Japan. Okay, so under exports for the United States, I can fill out, I can use a different color for this. I can say 700 boxes of masks were exported to Japan. Okay, if these were exports for Japan, these would have been imports for, if these were exports for the United States, then these would enter as imports for Japan. Okay, so these are two sides of the same coin. If it is our export, it is going to be a Japanese import. If it is a Japanese export, then it would be our import. Okay, so these two would match up. And then what is given to us is the United States imports 110 iPads from Japan. Okay, so when we look at the US, we're going to go to imports and we are going to say that we are importing 110 iPads from Japan. And since this is our import, it is going to enter as an export for Japan. Okay? and the rest of the numbers are going to be 0. Okay. So now remember what we said about consumption with trade. Consumption with trade equals production with trade plus imports minus exports. So when we go to this table, we are going to say that consumption under trade, to get those numbers, we have to add imports and subtract exports. Okay? So we're adding and subtracting, adding and subtracting, adding and subtracting, adding and subtracting, okay, to get to this number here. So let's take a look at this. If we add this up, consumption under trade is 270. Similarly, if you look at this right here, this is 2700. If you look at this right here, this is 130, and this is 700. Okay, so this is consumption under trade. And now let's compare this, okay, this row to production or consumption without trade, because production and consumption were equal. Okay, so for the United States, remember that for the United States, that number was 250, 2500 when we were not trading with another country. Okay, so let's write that down. 250 and 2500. Okay, and for Japan, that number was 120 and 600. Okay, so now we're going to talk about something that's known as gains from trade. Okay, and that is just the difference between consumption under trade, so this guy right here, minus consumption without trade. Okay, so for each column you're going to subtract off. So this is what you're going to do. Okay, so we're going to subtract this off, and we are going to look at what are gains from trade. If we traded with Japan, we basically gain 20 iPads, okay, than if we were not trading with Japan. Okay, similarly, we get 200 boxes of masks, more than what we could have got under no trade. Similarly, Japan, for Japan, the gains from trade are 10 iPads and 100 boxes of masks. Okay, so this last line is really important here, right? The gains that we have from trade, and for each country, for each good, this is positive. Okay, so what does that mean for us in terms of where we are? Okay, so consumption, let's draw those points. Okay, so if you think about consumption under trade, 270, 2700, that's going to be a point that is going to be outside the frontier. Okay, so a point like 270, 2700, which was not possible for Japan, puts us outside the frontier. So it becomes attainable if we trade with Japan. Similarly, for Japan, a point like 13700 is outside the frontier. Okay, so without trade, it would not be possible to consume this combination of the two goods. So both countries are better off, and therefore trade has made everyone better off.